Hello, Dan Perry again. TCP/IP Basics Part 3, Converting Decimal Numbers to Binary Numbers. In this video, we're going to learn how to convert our decimal numbers into binary numbers. Well, once again, we need to go back and look at the powers of 2 and remember starting at the leastmost bit on the right, it's 2 to the 0 or 1, 2, 4, 8, doubling each time. Now, there are a bunch of ways you can convert numbers, and most calculators today, especially any scientific and engineering calculators, can convert numbers from one system to another. The built-in calculator in Windows can also do that. Now we're going to look at the way to do it manually because on certification exams you're typically not allowed to bring a calculator in, so you have to do any conversions by hand. The method we're going to use is the repeated subtraction method, and I have found that that's probably the easiest way to do your conversion. Again, look at the powers of 2 table, keep it handy. Once you've been doing it a few 100,000 times, maybe you won't need it, but until you're very comfortable with those powers of 2, you probably want to keep that table handy. Now, write down the decimal number you would like to convert. Now, take the largest number in that powers of 2 table that is still smaller than the number you're subtracting, write it down and do a subtraction. Then do the same thing. Now, if the next smallest number there, or the next number down from the first time, say it was 64, if the remainder is less than 32, because that's the next smallest number, you won't be able to subtract that out. So you're going to write a 0 down for that one where you wrote a 1 down when it would subtract. And then you're going to continue with those steps, writing down ones whenever you can subtract the next smaller power of 2, zeros when you can no longer subtract, or you can't subtract that, until you get to the least significant bit. For this example, we start with the number 175. Now, looking at our powers of 2, it will go into the 128, so we bring down a 1, subtract the 128, leaving us 47. We can't get the 64, the next smallest number, will not go into 47, so we bring down a 0. The next smaller number in the powers of 2 is 32. 47 will go into 32, so we bring down a 1, subtract off the 32, giving us 15. A 16 won't go into 15, so there we get a 0. The 8 will, so we get a 1 for that position when we subtract the 8 from the 15, leaving us 7. The 4's power will go into it, so we get a 1 for that. Subtract off the 4 from the 7, leaves us 3. The 2 will also go into the 3, so we get a 1 for that bit position. Subtracting that leaves us a 1, and the final 1 in the 1's position gives us a 1, and a final answer of 1, 0, 1, 0, 1, 1, 1. Let's try this again, this time with 160. With the 160, we can subtract off the 128, gives us a 1. That leaves us 32. That will not go into the 64, so put it down a 0, but it goes evenly into the 32, so we bring down a 1, and then since there's no remainder, we write down zeros for all of the rest of the powers, giving us a 1, 0, 1, 0, 0, 0, 0, 0 for our final result. Here's another one with the 115. It will not go into the 128, so we've got a 0 for the leading or most significant bit. We'll go into the 64, so we bring down a 1. subtract that off, gives us 51. That will go into the 32, so we bring down a 1, leaving us 19. That will go into the 16, bring down a 1, leaving us 3. Well, that will not go into either the 8 or the 4, so we end up with, or bring down 2 zeros. It will go into 2, so we bring down a 2 or 1 there, subtract off the 2, giving us a 1 with the final 1 for the least significant bit. And we end up with an answer of 0, 1, 1, 1, 0, 0, 1, 1. Now, I hope that helps you in converting the numbers. Next time we're going to look at going the other direction. We're going to convert binary numbers into decimal numbers.